Hello and welcome to the latest edition of Self Builder and Renovator. And you may wonder why I'm standing in front of an 18th century church in Banbury. The answer lies in the technology used to keep the place warm. If you can heat a place like this, imagine what it can do for your self-built home. And I'm joined by Keith Westcott, who is one of the world's leading experts on underfloor heating. He's from the company Thermoplane. He's involved in all sorts of industry bodies, including one which advises the government on microgeneration. So he certainly knows what he's talking about. And if I could ask you, first of all, Keith, a church, you know, they're not exactly renowned for being easy places to heat. So what was this job like?
Well, this was quite a difficult building to look at heating. It's got very high ceilings, very cold throughout the winter periods. But really what we were trying to look at is how can we localise the heat for people which are actually on the stage. You know, they have different concerts here, and it was almost impossible to look at trying to get the air temperature up across the whole of the church to say 20 degrees or so. But what we could do with underfloor heating, because of the radiant nature of the underfloor heating system, is look at keeping heat within the first sort of 2.5 metres all around this stage, giving that sort of feeling of warmth, even though the air temperature wasn't necessarily any warmer.
Now, you gave me a really good example earlier on about how to understand this. It's like being outside on a frosty day, isn't it?
It is. A great example of this is people who are building their houses at the moment and going through a -1 day. You know, the sun is out, but stand in the shade and it's freezing cold. Stand into the sun and you've got that feeling of warmth. But actually the ambient air temperature hasn't changed. It's still -1. It's the feeling of the radiant heat touching you which gives you that feeling of warmth.
Now, I am not that learned, but I'm of the understanding that heat rises. Therefore, why doesn't all the heat just go straight up into this large vaulted ceiling here and leave everyone freezing down below?
Well, underfloor heating is the only form of heat which actually doesn't naturally rise. And it can be quite a problem, especially if you're building your own house, in trying to understand how underfloor heating works. With something like a first floor, if you don't insulate underneath the underfloor heating, you know, the heat can travel downwards onto your ceiling and give you a radiant plane, which will just as efficiently heat downwards as it does upward.
I suppose one of the issues with underfloor heating is the fact that, as the name suggests, when it radiates, it goes out from those pipes in all directions. And one of the key things must be, I mean, you've talked about first floor, maintaining the heat moving in the direction that you want it to go, kind of thing. How do you cheat it? How do you steer it?
Well, the first thing, you've got to make sure you've got a greater resistance underneath the pipe than you have above it. And in a rule of thumb, as long as you've got 10 times the resistance beneath that pipe, heat will always take its easiest path, which up to the surface. But of course, different flooring materials have different resistance qualities. So a stage like this, which is actually a timber floor, means that we have to raise our flow temperature underneath the wood to pass the heat through the actual wood and give you a surface temperature. And it's actually the difference between the surface temperature and the air that gives you the output. Wood, unfortunately, you can only heat to 27 degrees as a surface temperature, whereas a stone finish, you can get up to 29. That means you get a greater output from the wood, from the stone floor than you do from the wooden floor.
Right. Now, if you were doing this again, this is a 10-year-old installation, you would do it somewhat differently from the way it was done, wouldn't you? I mean, what's the really modern, the really up-to-date way of doing these things?
Well, of course, in trying to match underfloor heating to, say, renewable technologies, we're always trying to look at reducing the flow temperature to suit, say, something like a heat pump. The problem being is that as you actually reduce flow temperatures, the inertia in the mass becomes greater, so it's harder to respond once you lower your flow temperature. So in these instances now, we'd look at a thin thermal screed, and that means it's a very responsive screed, but also allows you to get to the higher surface temperatures to get the greater outputs if you need them. So recently we finished a church in Glasgow where in that instance they've put a timber decking down, the screed goes on top of it, and the whole system works as a screeded system rather than a timber framed system.
I suppose the important thing is to take some advice from the people you're buying it from and not just think you can just stick it in any old how and it's going to work.
Yeah, the underfloor heating specialist should be able to help you with these decisions. One thing which is important, you'll have one flow temperature coming from your heat provider, whether that's renewables or whether it's from a gas boiler. And you need different temperatures to deal with different types of constructions. So if you have got a timber frame building, now what we would try and do is actually put a screed on top of that timber suspended floor, so the first floor reacts very much like the ground floor. But the other ways of doing this is to put in aluminium plates like you have in this actual structure, but they need higher flow temperatures. So that means that the first floor and ground floor can be two completely different flow temperatures that you require. So the actual key to this moving forward, we think, is to have a very conductive material like a thermal screed on both the ground floors and first floors, so that you could be working at, say, around 30 degrees as a flow temperature. Fantastically low temperature for the renewables.
Keith, that's absolutely fascinating, absolutely fantastically mind-blowing stuff that you can achieve with underfloor heating. And in a couple of weeks, we're going to be looking at the sciencey stuff behind Thermoplane, this product, this liquid screed which you can put under your underfloor heating, which will massively improve the results that you get from it. If you have any questions about underfloor heating that you would like Keith to ask, get in touch with us via the website and we'll pick his brains for you.